Today I'm going to relay a few thoughts on what it is we do in irrigation ag and its contribution, direction, and possibly value in production ag. Many times we assume folks, even within the irrigation community, know the scope and depth of what we do, and we've come to find out that that's not necessarily true. So I've been asked to comment on a few efforts and that I know have been conducted for two reasons. First, because I was there, and second, because typically I was a part of them. Then I'd like to mention possibly a few items regarding what we're currently working on and a few thoughts on possibly where we're headed. Now, I don't need to tell most of you that water is truly the key to our way of life. But some folks among us don't realize that. And if you don't believe that, all you have to do is drive around town and you can see that they're ignorant of that fact. This is not only a big deal here in the Panhandle, but elsewhere as well. And there are many folks in the state that want our water, and in time they may get it. So what we definitely do here has consequence. I recently did a national presentation out west and stated that when the water's gone, the economy's gone. And when the economy's gone, the people are usually gone with it. So we need to be real careful what we're doing. So why do we care? Well, we care because our past has indicated that we've helped feed the world population, and that's not going to change anytime soon in my view. So if we look at what the projected global populations are, we get an idea of where we're going to have to go forward in time. It doesn't matter which source we look at. We're going to have to increase the food, fiber, and feed outputs to meet these needs. If we look at the U.S. national stats, probably help to look where we've been. Current population is about 308 million. It's increased by about roughly 10% over the last decade, projected to be about 364 million by 2030, or we're going to have an increase of about 18% over the next 20 years. It's about a 1% average gain per year. Texas, current populations are at about 25 million in 2009. Nearly over that same period, from 2000, we increased about 19%. It's projected to increase to about 34 million, or we're going to have about a 34% gain. So we're about doubling what the national rate is. And either of those people increased by birth or they migrated to Texas. But one thing's pretty certain, they did not migrate to the Panhandle. So what about the Panhandle? The Panhandle population is currently at about 460,000. It's projected to go to about 560, or about a 23% gain, but we need to keep perspective on that. We only have about 1% of the 1.8% of the population, or less than 2% here, and that's even expected to decline. So these numbers come from the state values. In any case, we're going to have to produce more with less over time to meet those food, fiber, and feed needs. So, how are we going to meet that increasing population base? That's the real question for research and production. And to increase that production, we're going to have to increase our research efforts. Well, first, we need to have a good water plan, as Harold mentioned. It needs to include our current status of where we're at with regard to water supplies and production demands. We do have this. However, in during some recent elections, I read in the paper that we didn't even have a water plan in our area, and that's simply not true. Ag research personnel were major contributors to our comprehensive regional water plan since 1999. Currently working on our third version. The inputs into that water plan are based on sound science and data values and result in some of the best plans this state's ever seen in terms of water planning, in my view. And I've been around a few decades, as many of you in the audience have. So how are we really going to meet that? We're going to meet it one way. We're going to meet it through production and technology, of course. In nearly every crisis this country's ever faced, technology's bailed us out. You think about that a minute. And I don't think it's going to change in this case either. We're going to depend on research and new technologies to bail us out. We're located in Region A, up here in the Panhandle region, of course. And it has some value to us to know where we're currently at in terms of percent production. Ag's really big in our area. We seem to think that, or is it? We produce a lot of the percentages in terms of the outputs in the state of Texas. We accommodate for about 52% of the corn. That's why we use a lot of the water, 50% of the wheat, 11% of the cotton, 61% of the ensilage, 74% of the cattle on feed, 94% of the swine, and 24%. And the irrigation is a major driving force of that production that provides that. But as Harold indicated, can we sustain this going forward in the long term? And the answer is maybe. We need to look at our inputs on production. Of course, number one is water, period. There's no doubt about that. Land, we got more land than we got water. It's typically not been a constraint for decades. We got some of the most productive land in the state, and we also have a good production climate to go with it. Other impacts are policy, operations costs, and regulations. Yeah, I said regulations. Recognize, as Harold indicated, not all regulations are bad and generally in place for the good of all users. Part of research's role with respect to regulations is to provide an unbiased assessment or analysis of those potential regulations, the programs, the policies, and the strategies used within those. The water. Irrigation accounts for the majority of production. Remember Terry saying one time, irrigation accounts for 90% of the production in the Panhandle. That puts it in pretty strong perspective. That production takes a lot of water. It's the basis for our economy, our jobs, food security, and our way of life. And it does take a lot of water. According to our latest water plan, we pump about 1.47 million acre feet annually for our production needs. That's ag and livestock. And ag uses about 89% of all the water resource for crop production. Most of that water, of course, comes from the Ogallala and is classified as superior by the state of Texas. Past technology impacts. It would do well for us to look at a few things. Some of the history and performance of ag research water programs I've been involved in, water planning efforts and documentation, irrigation and crop water reductions, production efficiency gains and improvements, new irrigation systems development and expansion, enhanced ET development and production management tools, and better educational and awareness materials for all water users, both urban and rural. So how do we derive the current new water plan methodology? The state gave each region a choice to either accept their estimates in 1999 or come up with their own values. We chose the latter and developed a completely new water methodology for Region A that the state is not only liked but adopted in other areas of the state of Texas. And it's proven beneficial and accurate in this region particularly, in my view, and it's been confirmed by independent results as well as records that the water districts record. The water plan we have now is more detailed than ever before and in our region's history. And we developed this methodology, and it served us well with the scientific inputs. Looking at the big picture in the water panhandle also brings us to the plan we helped underpin with research and producer-based data. Literally, hundreds of thousands of data points, many derived through research, were used in the plan. Today, we know more about what we have, where it's being used, and what it's being used for. Just recently, the amount of water in storage was updated. We've got better estimates of that. We've got somewhere on the order of about 230 million acre feet left in storage. Remember I said we're pumping about about 1.5 million acre feet a year. So how long can we keep doing that? The water plan also targeted what changes had to be made to get supply to meet demands. As expected, any cuts in that water allocation was going to come out of agriculture, has been typical over past times throughout the western U.S. So, did the plan indicate a doomsday forecast? No, but it did indicate require shifts in our current practices. It also identified as to what solutions were going to entail, and to some a surprise. To others, virtually no change. One thing it also did was to make us realize we have to work together more than ever before, and that the low-hanging fruit type solutions of the past are gone. As Harold mentioned, drilling more holes or drilling more wells was not going to be a sustainable solution. It also let us look at what the needs and targets of the future were going to be, like maybe 5 bale cotton, 400 bushel corn, bioenergy solutions, cheaper desal, improved energy and production efficiencies with our new genetic cultivars. Are these the new potentials that we can attain with going forward? Some of these are actually nearly attained, with others still horizontal. One thing it did, the planning effort also did, was to indicate and reinforce that research was a key element to our future and was needed by both the public and private sectors. Private and industry-based research typically are concerned with bottom lines and profits. Public efforts generally take a more benefit for all approach in developments and resource utilization. The two are equal in terms of value and consideration. Given the challenge and cost of the needed advances in production, it became evident that no one sector alone could afford all the efforts. There are still basic items in irrigation research that need to be determined today. All the answers are not known despite what you may hear. So looking back, what has ag research done in particular to meet or reduce those water needs? Some come to mind. The busheling lysimeters built in the mid-'80s have been used to derive and determine the very accurate crop coefficients that we use today. Before that, we used average-based monthly crop water use values and thought they were good. They were okay, but not good enough to be used in today's world. Today, crop coefficients are used to determine accurate and crop-specific ET needs and estimates using the data collected from the ET networks or other sources. Later, irrigation schedulers and application tools were developed based on crop ET values and are still being upgraded to address new demands and challenges with newer practices and varieties. When done right, these are about as high-tech a water units as you can get in water resources, and the data are invaluable for many water applications. Many thanks to our friend and colleague, Dr. Terry Howell, ARS Busheling, who has spent a lifetime developing and operating these facilities. I wonder how many of you realize that. Folks all over the world come, appreciate, and respect the data that is derived from these units located literally in our own backyard. To develop crop data is one thing, but we also developed a system to deliver that data to researchers and to the public for free for nearly 20 years on a daily basis. The data gained from these efforts reduced irrigation applications and overwatering by an average of 2 inches per year. This equated annually to about an $18 to $20 million value in reduced energy costs and saved the water. The cost of operations today currently prevent us from continuing the system as we had it in the past, and we're evaluating alternatives at this time. The ET network data was also used in the groundwater availability models in the water plan and shook up some parties pretty badly when the first forecasted results came out, saying if we kept doing what we're doing at the rate we're doing it and the way we're doing it, we're going to end up with this. Basically a depleted aquifer, particularly around the Dalhart region in Dallam County. So, how much has ag research really reduced water use? Since the 1980s, corn irrigation's been reduced from using a value, and I remember this, Nolan. We used to say if you didn't have 12.5 gallons per minute per acre, you have no business growing corn. Today we're at 5. And with some of the studies we're doing, we're even less than that. We used to run sprinklers at 100 PSI. We're at 6 today. That didn't just happen. It was researched thoroughly, I assure you. Other crops besides corn have had similar reductions. We changed sprinkler types from impact to MESA, LISA, and LIPA. Then we solved the runoff problems that those changes made. We increased the use of sprinklers over furrow with NRCS and EQIP programs. We also started drip application for some applications. We fostered more efficient use of rainfall and rainfall storage. We did away with the pre-water practices because less than 40% of that water could typically be accounted for in the spring when it was applied in the fall. And what about the conservation tillage and the minimum tillage practices that are being still implemented today? In precision ag, we saved producers millions of dollars, not by what we did, but by what we didn't do. We advocated non-adoption of a lot of the technologies being sold within our area. Why? As Harold said, there was no return on investment and very intensive data management requirements. These reductions jointly have saved Panhandle producers millions, and they keep on saving annually. Does that picture bring back memories for a lot of us? It should. We really have come a long way.